because otherwise you will forget all those key terms. So please take your times to have notebook and pen with you, or otherwise you can take the notes on your laptop. So first important term is counterfactual explanations. So explainable AI can also generate perfectual explanations. It means that it can generate the explanation that okay, at present you have a very high chance of stroke, but if you could decrease your body mass index to 25, the prediction will be 70% low stroke. So from this example, you can see that explainable AI can generate the counterfacts that can move this person from non-desirable class to desirable. At present, non-desirable class is stroke. He has a high chances of it. And of course, we want to get the prediction as low stroke. So in order to move from decrease your body weight, I hope you can understand that this is very important information for this person, and he can act on this information so that he can move from stroke to no stroke class. And these type of explanations can be generated by our explainable AI models, and these explanations are called as counterfactual explanations. You got? Let us take one more example. So let's suppose this person visit the bank and his loan has been rejected. Now he want to know what he should do so that his loan can be approved. So at present, the prediction is loan rejected. He wished to move from non-desirable class to desirable class, which is loan approved. And the system can generate counterfactual like this, that increase your income by 10,000 US dollars so that you can move from original class loan rejected to loan approved. So in order to get your loan approved, you should increase your income by this amount. Or it can generate counterfactual explanation like this: increase your income by 5,000 and have one more year of credit history. This will help you to move from loan rejected to loan approved. So my point is this: explainable AI can generate multiple counterfactuals for the benefit of the end user. And through these examples, you can clearly understand that explainable AI is very important for end user, because in this case, it can generate explanations that why this person has a high chances of stroke like this, and it can even also provide counterfactual explanation that what action he should take so that he can move from stroke to no stroke class, or from loan rejected to loan approval class. So at this point, if anyone have any question, please unmute yourself and you can ask me any question. So please don't shy to ask the question. Yeah, anyone? Okay, so now I'm going to discuss. Yeah, good morning.
कैन वी आस्क कि जो एक्सप्लेनेबल एआई है हम इसको क्लॉथ प्रेडिक्शन में लगा सकते हैं, फैशन अप्रैल?
Yes, we can apply this on predictions that we can generate explanation like this. For example, the system is recommending a particular clothes to a particular person, then we can generate the explanation like this, that why this particular product has been recommended to the person. So you can generate explanation that like this, because you like this particular color, or your gender is this, your age is this. So based on that, you are recommending this product to the person. So when you are recommending the product, you can generate explanation that why this product has been recommended to the person, or you can generate a prediction that because your friend has purchased this, that's why my model is recommending this product to the person. So in all the application where we are making some prediction, you can find the use of this explainable AI and you can apply this in those domains.
Good morning, sir.
So,
thank you, sir.
Good morning.
सर हम जो एक्सप्लेनेबल एआई है इसके लिए कोई पर्टिकुलर मॉडल्स वगैरह भी होते हैं जिससे हम
I will discuss that. So okay, just wait for it. So now we are going to discuss another important application, that how explainable AI is important for AI developers. So in order to understand this case, that why explainable AI is important for AI developers, let us consider this example. So here I'm considering a image classifier where I have few images of a ski dog and wolf. Each of these images have been labeled with H and W. H mean that all of these images are of husky dog, and W mean that all these images are of wolf. So this is very important case study. The developers train their convolutional neural network on these images, and they achieved very good accuracy. So when they then they test their model on this image. This is the image of the husky dog. The model has very good accuracy, but when they test it on husky dog, this husky dog was classified as wolf. So they were surprised that why this husky dog has been classified as wolf, because the model is already having very good accuracy. So then they apply explainable AI to understand what are the pixel area on which my model is focusing. So explainable AI can generate those highlight. Explainable AI model can highlight those pixel areas in the image that our model is looking at. So when they apply explainable AI to understand what pixels are important in this, so they came to know about this. So when they apply explainable AI, they came to know that the model is predicting it wolf because it has eyes in the background. So the model is not at all looking at any of the feature of the dog. The model is just looking in the eyes in the background, and because this is having eyes in the background, the model is generating it as a wolf. So they're surprised. So actually, they have not built a husky dog and wolf classifier. They just built a system to detect eyes in the background. So when they relook into all the images, they came to know that all the images of wolf has eyes in the background. So you can see that all these images of the wolf has eyes in the background, and all these husky dog has no eyes in the background. So when they given this input image to the classifier or the machine learning model, so there was eyes in the background, so the model was predicting wolf. So from this explainable AI, they came to know about the problem in their model, and this way it helped the AI developer to solve this issue. And in order to solve this issue, uh, they come across two possible solutions. One solution is to collect more images of wolf without eyes, and second, either to remove background before processing or before building machine learning model. So they able to identify this problem only by applying explainable AI, because explainable AI can generate the pixel areas from the image that are important for that classifier. So the classifier is looking at eyes in the background for making this prediction, and they able to identify the problem in their model by applying explainable AI. So my point is this, that explainable AI is very important for developers, and by applying explainable AI, developer can know about the problems in their model, and they can use this information to improve the accuracy of their stuff. So this is the second important application for AI developers. So as I discussed earlier, that explainable AI is also very important for regulators. So now I'm going to discuss that why and how explainable AI can be used by regulators. So regulators are those persons who enforce that there should not be any bias in the model, who enforce regulations. So they are regulatory bodies from the government, and their job is to enforce the regulations. So explainable AI can be used by these regulators. And recently, European Union come up with a important rule named as General Data Protection Regulation, commonly called as GDPR. And this rule state that whenever a company is using AI for making any predictions, so whenever a company is using AI for making any prediction, it is the responsibility of that organization to generate explanations that why the model is rejecting or approving a particular law. So you can read this point, that if a organization is using artificial intelligence for generating decisions, then meaningful explanation of the logic involved is compulsory for that organization. So it is the responsibility of the organization to provide explanations for the predictions made by AI model. AI models. So that's why regulators want to make it sure that your software should not be suffering from any bias. There is one very common case study in US. We called this case study as Compass, which is used to identify which actually suffered with black bias. So actually, they were proposing a system for this judiciary system, and the idea was that the judge in the US court will use this software to check that whether it is safe to release the person or not. So it will assess the likelihood of the defendant becoming a lawbreaker. So they are planning to use this software to check that whether the person is going to break law in future or not. So the system is making some kind of prediction, and if system is saying that the person has very high chance of breaking the law again, then the judge may decide against the release of that person. So that software is very important, and this software should not suffer from any bias. But by applying explainable AI, they came to know that this software is suffered with a bias against black people, because they applied it and they checked that black people were mostly wrongly classified as lawbreaker than whites. For example, these two persons have similar kind of history, but the model is predicting this white as a low risk person, as black is considered as very high risk. So both the person have similar kind of attributes, but they were classified into different classes. By applying explainable AI, we can understand the behavior of our model to to check any kind of biases in our model, and we can apply explainable AI to check that whether our model is suffering from any kind of bias or not. And this information is very important for regulators. So with this, I conclude that explainable AI is very important for end user. I discussed the example of a person who has visited the hospital, and he has very high chance of stroke. And for example, a person whose loan has been rejected. So it is very important for end user to know why he has high chance of stroke or why his loan has been rejected. Similarly, we can apply explainable AI for to help AI developers. So in this, you remember the example of husky dog and wolf. So by applying explainable AI, they came to know that the problem in their model, and they can act on those guidelines and further improve the accuracy. And of course, it is also very important for regulators to identify any kind of biases in their model. And if there are some biases in the model, they can suggest to stop the use of that particular software. So this is the point, that explainable AI is very important for end user, AI developer, and regulators. So with this, I can conclude that explainable AI is very useful way to empower the individuals against undesirable effects, because it is used to implement the right of explanations. So it provides end user with the ability to generate explanations. It helps the people to make better decisions. It helps to make better AI system, and it is help. Explainable AI is useful to preserve and expand artificial intelligence. So if we wish to apply AI on multiple applications, it's very important to have explainable AI at place, because if explainable AI is at place, then only we can preserve and expand the range of artificial intelligence. Otherwise, we can't apply in multiple domains, because GDP is only compulsory to generate the explanations, and explanations can only be generated by explainable AI. So this is my point, that why explainable AI is very important in these days. So if any one of you have any doubt at this point, you can ask me any question.
Sir, good morning.
Good morning.
Sir, I am Tejinder Singh from Chandigarh University. Sir,
Yeah.
I just wanted to know that in case of stock prediction, like we use artificial intelligence in the form of algo trading, sir, algorithms. So the regulators from time to time come with their own rules that now application program interface is allowed, sometimes it's not allowed. So in the smooth application of algorithm in the stock market gets affected by the regulated circulars from time to time. So sir, I mean, can you, like the example you have given, explainable this AI? So we can also use the same in the stock
Yes,
prediction.
yes, yeah. It's very important that we can apply explainable AI in stock market prediction, because this is the example of time series analysis. So
Okay, sir.
explainable AI can be applied on time series analysis to generate explanations. So in this case, you can consider the example like this. For example, you are saying that the stock market will drop. So you can generate the explanation that why stock market is going to drop in next day or next couple of days. So otherwise your model is simply saying that it will go up or it will go down. But with explainable AI, we can generate the explanation that why it is going to be up and why it is going to be down. And by providing the information of why, you can make your model more trustworthy. So actually, explainable AI comes under trustworthy AI, and it helps you increase the confidence of your users in your system. So if you can explain to your user that okay, the stock market will rise due to these reasons, so automatically if these reasons which are provided by your model are making some sense, then it will improve the trust of the end user. So explainable AI is a way to move towards building trustworthy AI systems.
So that means we can add the relevant variables in our model.
Yes, yes. So we can add a layer of explainable AI over existing machine learning model to generate explanation that why your prediction is going to be up or down.
Okay, thanks a lot, sir. And so, is there any software also that you can suggest? For
Yeah, I will be suggesting that in this session. Yes, we will be discussing.
Right. Thank you so much.
So now, so at this point, we reached at a stage where we can discuss more technically that why explanations are required and why it is tough to generate those explanations. So I hope you know that all these classifiers are used in machine learning to make various kind of predictions. So you all are familiar with classifier like decision tree, participant equation, random forest, KNN, support vector machine, Rn. So all of these classifiers are used for making predictions, and these classifiers are actually divided into two types. One is glass box and second is black box. So this time I am introducing another term, glass box and black box. So I suggest you to write this one in your notebook so that you can refer this term in future. So season tree and logistic regression, these two classifiers fall under the category of glass box, while all other traditional machine learning classifier like random forest, KNN, support vector machine, CNN, RNN are considered as black box. So now the question is why they are called as glass box and why these are called as black box. So in order to understand why they are called as glass box, it's important to understand their working principle. So decision tree is actually built a inverted tree. So here we have some kind of root nodes and decision nodes, and based on that we are making decision that whether the person is going to purchase the product or not. So let us suppose this is the decision tree to make prediction that whether the person is going to purchase a mobile or not. So here I am saying that the decision node, first decision node is cost. So first the person will take a note about the cost. If cost is more than 25,000, the person is not going to buy it. Then if cost is less, the person will focus on battery. After this, person will focus on memory. Then person will focus on camera. And if everything goes well, then person will buy the product. Otherwise, person will not buy the product. So all these are called as leaf nodes, and all these are decision nodes. And you can see that this decision node, this decision tree is very easy to explain, and it is called as by design interpretable model. So decision tree are by design interpretable models. Let us consider one more example. So let us suppose this is my stroke data set, and I have to predict that whether the customer is having high chance of stroke or not. So you can make prediction on the basis of age, body mass index, and hypertension. So let's suppose this is my decision tree. So you will think the age of the person. So if age is greater than 50, then you will be considering his body mass index. Body mass index is less than 25, you will be saying that the person will have no stroke. So you can easily see that you can make if-else rules on the decision tree, and it is very interpretable. It is very understandable. So decision tree is considered as by design interpretable model, and you can understand the output which is generated by decision tree. Same way, the output which is generated by my regression model, that is logistic regression model, is also very interpretable. In case of regression, we actually got an equation like this, which is which say that this is my output attribute and x1, x2, and xn are my input attribute. So every input attribute will get some weight by our model, and based on that, it will predict the value of y. So logistic regression is actually building this equation y equal to this, and in this case x1, x2, xn are your input attributes, and b1, b2, bn are their weight, and based on their weight we can check that whether the attribute is important or not. So let me throw a question to you. So let's suppose I have y equal to this. Can you tell me what is the least important attribute in this equation based on the weight they have? So here I am predicting the value of y on the basis of married, applicant income, gender, loan amount term, and city. Based on their weight, can you tell me which attribute is least important in this prediction?
City.
City. Why this is city? Because this has a weight 0. So if a attribute has a weight 0, you can say that this attribute is not important. Can you tell me what is the most important attribute in making the prediction?
Loan amount. The loan amount.
The loan amount.
Loan amount.
So loan amount term, actually, this loan amount term has a weight 0.98. So the attribute which is having maximum weight is most important, and attribute which is having the least weight or 0 weight is least important. So this way we can understand that which attribute are important and which attribute are not important, and this is very easy to understand in case of logistic regression. So my point is that in case of decision tree, you are building the tree which is easy to understand, and same way in logistic regression you are getting an equation which is also very easy to understand. So that's why we are calling this as glass box, because these models are very easy to explain. From the equation you can see that okay, this city is not important or loan amount is most important attribute. So you can easily tell by referring the equation, or you can easily tell everything by referring the decision tree. So that's why decision tree and logistic regression are considered as glass box model, while all other models are considered as black boxes. Now, the question is, if these two models are interpretable, so if these two models are interpretable, then we can design all the machine learning, then we can solve all the problems with only decision tree and logistic regression, and my model will be explainable. So I want to conclude that your model will be explainable if you are using decision tree and logistic regression. So my question is why we are not building, why we are not solving all the problems with only decision tree and logistic regression? Because they are interpretable. So we can make a conclusion that okay, let's solve all the problems with decision tree and logistic regression because they are interpretable. But we are not using decision tree and logistic regression to solve all the problems. Why? Anyone?
Sir, because decision tree is not able to solve every problem, like complex problem, like which convolutional neural network can solve, decision tree cannot solve that problem.
Yeah, very good. So the problem in decision tree and logistic regression is that they are not that accurate and it cannot solve complex problems. So if you look into this trade-off, so this trade-off is very important, and we called this trade-off as interpretability versus accuracy. So please everyone concentrate on this table graph. This graph is very important, and this graph is considered as interpretability versus accuracy. On y-axis, I am having interpretability. On x-axis, I am having accuracy, and here I have listed all the classifiers. Now you can see that linear regression has very high interpretability, but this has very low accuracy. Decision tree again has very good interpretability, but it is very poor in accuracy. So these two models are very good in interpretability, but they are very poor in accuracy. While nowadays we are using deep learning models or deep neural network models, they have very high accuracy, but they are very poor in interpretability. So there is a trade-off between accuracy and interpretability. If you want interpretability, you can go linear regression, decision tree, but they are not accurate. But if you want accuracy, then the problem is that they are not interpretable. So we called all these models which are not that interpretable as black box, while those models which are interpretable are considered as glass box. Now my question is, if you have to make a choice between interpretability and accuracy, what will be your vote? Where you will go, with interpretability or accuracy? If you have to build a machine learning model.
Accuracy.
Yeah, accuracy. Because accuracy is the first topmost requirement. Because if your system is not accurate, then there is no fun of making machine learning model. Because in order to make a product, your system should be first of all accurate. Then interpretability come into the picture. But if your model is not accurate, no one is going to use your model, and then interpretability is of no use. So the first important requirement is to have accurate model. So that's why we use deep learning model to build most accurate model. So once we have most accurate model with us, then researchers start thinking to solve the problem of interpretability because they are not interpretable. So you can see that in earlier machine learning research, uh, the earlier machine learning research was on building more accurate models, so that we moved from random forest to support vector machine to deep neural network to CNN and RNN, and we achieved that by having deep neural networks. So we solved the problem of uh, getting highly accurate models in recent time. But now the challenge is accuracy is already achieved. Now the challenge is, now the researchers start thinking about the problem of interpretability, and now they are making some technology which can make these black box predictions more understandable. So that's why we are having now black boxes, and all of these black boxes are implemented with the help of neural network. They are taking some kind of input, producing some kind of output, and there are thousands of hidden layers in between, and there are billions of parameters which are stored in between, and even the developer don't understand why their model is making that prediction, because everything is going inside this black box and no one understand what kind of weight the machine is getting. So we are simply getting accurate output, we simply know that, but how what is the interpretation of their neural network, no one understands that. So that's why explainable AI come into the picture, and explainable AI is actually used to open the black box so that we can generate some kind of explanation for these black boxes. I hope that you got a clear idea that earlier our target was to build accurate models. So we keep on working on building or to inventing new classifiers, and finally we end up with deep neural networks which are accurate and efficient, but they were not interpretable. So then researchers start thinking on this interpretability problem, and then they worked on explainable AI, which is actually helped to open these black boxes, and it helps us to make these black boxes more understandable. So this is the journey from building highly accurate system to now building interpretable system. And here we have a neural network, and we simply know input and output. We did not know anything what is going inside these models, but with the help of explainable AI, we can generate explanations for these models, and that's why we are here at this point, and at this point, I'm just concluding that there are two ways to generate interpretable model. One way is to just use decision tree or logistical, but this way is not good because they are not accurate. So we use black boxes, but now we have to generate explanations for these black boxes. So we are at this stage where we are driving explanations for complex models, and we also called this technique as post hoc. So there are multiple ways through which we can generate explanations for our black boxes. And in this figure, I am showing you various approaches to generate explanations for our black boxes. And you can see that there are four major approaches to generate the explanations for our black boxes. And these are visual, feature importance, data points, and surrogate model. So at this point, I ask you if you have any question, you can ask me anything based on the content which we have discussed. Anyway.
मैं आस्था बोलो
Sir, what are the surrogate models?
Yeah, I will explain those things one by one. So I have to show them this animation to explain. So at this point, I request everyone to write down these points on your notebook. I hope you are carrying a notebook and pen with you. So there are four ways for generating black box explanations, and I'm going to explain all these approaches one by one, which will also cover surrogate models. So first approach is visual. So let's first discuss what is visual approach. So in visual approach, we simply produce different kind of correlation plots to understand the correlations between our attributes. So let's suppose on x-axis I will have one attribute, on y-axis I will have another attribute, and on these I will be finding out the correlation between one attribute and another attribute, and that correlation actually help me to understand some kind of my model. So that these correlations can be strong positive, that these correlations can be weak positive, as shown. You can see that here they are very strongly positive correlated, here they are very weakly correlated. This is strong and negative. You can see that the slope is negative and dots are very close to this, so we are calling this strong negative. Here they are away from my predicted line, so it is weak negative. This is moderate negative, and this is no correlation. So by using these correlation plots, we can make some sense of relationship among our attributes, and that can help me to understand my model. So one approach is to use visual representation by plotting, by using scatter plots and correlations, and this helped me to understand my model little bit, and this helped me to actually find out the relationship between two sets of data, and by understanding that relationship I can explain some of my predictions. But this is a very limited area, and visual is not used a lot because this has a very limited scope and very limited capability. The second approach is feature importance, and we use this approach a lot. So in this, we are finding the important features based on their score. So for example, let us consider this is a stroke data set, and for stroke data set, we have find out the feature importance. And you can see that the highest feature important is age. So it, and second highest important column is average glucose level, third is hypertension, fourth is heart disease, then we have body mass index, ever married, and so on. So this type of information is actually very useful to generate explanation. So here we are saying that the most important attribute to decide whether the person is having high chances of stroke or less chances of stroke is age. So if the person is old, then naturally he will have high chance of stroke, otherwise he may have less chance. Then second is the glucose level. If a person is having high chance of high glucose level, he will have high chance of stroke. Hypertension, heart disease, these are other attributes. So I hope you get a clear idea that if you have some kind of feature importance information with you, then you can explain your predictions, or then you can explain your results in a better way to end user. And this approach is called as feature importance. So we have discussed two approaches. One is visual, where we just use some scatter plots and correlation plots to understand the relationship between two attributes. Second is feature importance, where we have used summary, and they are generating some kind of information like this. Age is most important as compared to average glucose level as compared to hypertension, and this way we can generate better explainable model. The third point is data points. The third approach is data points. Here, on the basis of data points, we can analyze or investigate our model more deeply. So, what is this? So, here, to understand or to investigate our model more deeply, we can use a tool called as what if tool. So, here, first time I am introducing a tool to you, and that tool is what if tool. This is a tool from Google, and this tool is actually help us to generate explanations. And here you can see that all these are my data points, and these data points are classified into two classes. Red is one class and blue is my second class. You can select any data points, and here you will be seeing the detail of the selected data point. So here I have selected this data point, and it indicates that the selected data point has age this, income this, social class order this. So you can investigate all his input attributes and class. So this way you can check the correlation between input attributes and the predicted class. So let's suppose you have selected two different classes. So if you selected data from two different classes, then their data should be different. And if their data is same, then you can identify some kind of biases in our model. So my point and my conclusion is that by using data points, we can closely analyze the biases present in our model, and this approach is called as data points. And for analyzing our models on the basis of data points, we can use a tool from Google, and the name of that tool is, can anybody name me the tool of that tool for data points? What is the name of tool?
What if tool?
You can, yeah, so we can use what if tool, and in this what if tool you can select any data point, and it will display its corresponding values, and this way you can generate explanations, or this way you can understand your output in a better way. So now we reached at the fourth point, and the fourth point is surrogate models. So let's discuss what is surrogate model. So surrogate model is used to build a simple model around the complex one. So surrogate models are used to build a simple model around the complex one. What it means? So let's suppose this is a person, and this person has a high chances of stroke, and we want to generate explanation for this data point. So if you look at the overall model is complex. So this line indicates total model, and you can see that this model is non-linear, and this model is very complex, and I can't generate any explanation based on this whole model. So what we are doing, we just zoom into the selected data point. So you will select a data point and zoom into that. So if you zoom into this area, you will get something, you will get a picture something like this. So if you zoom into this area, you will get this data point, and here you can see that this whole model is this whole non-linear model is actually look like a linear model. Now you are getting a straight line. So if you are getting a straight line, now it's easy to generate some kind of explanation at this stage. So here you can see that this is no stroke class, and this is a stroke class. This is my feature 2, and this is my feature 1. Can you tell me which feature is playing more important role in this prediction of stroke to no stroke? If you can look into this graph, can you tell me out of these two features, which feature is more important? Feature 2 or feature 1?
Feature 1.
Why feature 1 is more important? So if you increase the value of feature 1, so let's suppose if you increase the value of feature 1, it will go here. And if you decrease the value of feature 1, it will go here. So if you increase, what will be the class? If you increase the value of feature 1, what will be the class? This whole white area is stroke. So if you increase its value, what will be the output? It is still stroke.
Not stroke.
No, stroke. This white area is for stroke. So if you increase its value, it will go vertical. It will go here. So if it vertical, still it is stroke. And if you decrease it, it will be still stroke. So my point is that if you increase or decrease the value like this, so if you increase the value of this attribute, or if you decrease the value of this attribute, till it will be in the white area, and the white area is stroke, so there will be no change. But if you change the feature 2, so if you change the value of feature 2, what will happen? Can you tell me? If I increase the
Then
value of feature 2,
increase
what
the
will happen?
chances of no stroke.
Yeah, it will move from stroke to no stroke. So now, can you tell me which attribute is more important, feature 2 or feature 1?
2.
Yes. So feature 2 is more important, and this approach is called as line, because through line we can generate explanations. So this is called a surrogate model, because we are zooming into a record, and then by zooming into the record we can generate simple explanation for the selected data point. And here we are concluding that feature 1 is not that important, but feature 2 is more critical, because by increasing the value of feature 2 you can move from stroke to no stroke. And we called this model as line, which is a surrogate model. So this is the fourth approach, and these are the 4 ways through which we can generate explanations for our black box. So first is visual, where we just, can anybody tell me what concept we discussed for visual?
Correlation.
Correlation,
What?
very good. And
The different
for
type of
feature importance?
graphs.
And for feature importance?
Surrogate models. No.
No, feature importance.
Factors with the age or
Yeah.
hypertension.
Feature
For
importance,
example,
we are just generating the feature summary, that which
Yes,
columns are
yes.
important, column are not. And in third data point, which approach we use?
What if tool?
Yeah. So for data point, we used what if tool, and this is from Google, and this helps us to analyze our models. And last approach is surrogate, where I
Line.
have discussed this line model, and actually we zoom into a record and then can generate explanations. So these are 4 techniques for opening the black boxes. Now we reached at a point where we can finally conclude or discuss the categorization of explainability. Now I request everyone to write down this point on your notebook, and the topic is categorization of explainable AI. So you can see that we can divide explainable AI into 4 types. First is on the basis of agnosticity. Second category is on the basis of scope. Third is on the basis of data type. And fourth is on the basis of explanation. So please write down these points on your notebook. First is on the basis of agnosticity. So what is this agnosticity? So let's first discuss this point. So based on agnosticity, explainable AI model can be considered as model agnostic and model specific. Now what this means? If your explainable AI approach, just like line, so if your approach can be applied to any classifier, again I am repeating, if your explainable AI approach can be applied on any classifier, then it is considered as model agnostic. For example, line can be applied on any classifier, like you can apply line on support vector machine, random forest, naive Bayes, decision tree. So you can apply line on any classifier. So if you can apply line on explainable AI approach on any classifier, then it is called as model agnostic. But if your approach is only is specific to a particular classifier. For example, we have a model called as LRP, which is only applicable to neural network. Then it is called as model specific. So again, here I am explaining. So model agnostic mean that explainable AI algorithm can be applied on any kind of model. For example, line can be applied on support vector machine, naive-bayes, convolutional neural network. So it can be applied on any model. So if it can be applied on any model, we called it as model agnostic. But if explainable AI is only applicable to a specific machine learning model, such as neural network, then it is called as model specific. So we have a model called as LRP, which is only applicable on neural network. You can't apply this on support vector machine. So that's why this is called as model specific. So I hope you got my point that first categorization is on agnosticity, that whether your explainable AI model can be applied on any classifier or it is limited to a particular classifier. If it is limited to particular classifier, we call it as model specific. If it is applicable on any classifier, we call it as model agnostic. Any doubt?
No.
Then second categorization is on the basis of scope. So if your model is only explaining one record, then we called it as local. Local mean that it is explaining only one record, and global mean that it is explaining all the record. So we discussed the line. So in the line, we are explaining all the record, or we are just explaining one record.
One record.
Yeah. So that's why line is local. So in line, L actually stand for local. So line is a local model because here you are only explainable. You are only generating explanation for one record. If you generate explanation of all the records, then it is considered as global. So here you can see that this picture. So if you only generate the explanation of this one individual record, then it is called as local interpretation. And if you consider all the records of the model, then it is considered as global interpretation. So the scope of explainable AI can be local or it can be global. And this is the second categorization of explainable AI. Are you getting this point? The third type is on the basis of data type. It means that your explainable AI approach can be applied on textual data or tabular data or some kind of image data. So you can apply explainable AI on textual data. You can even apply this on image data. You can even apply this on tabular data. So based on that, you can identify the type of your explainable AI model, that is it capable to apply on textual, image or tabular data. So this is the third type. And third type is on the basis of data type, and it can be textual, tabular or image. And fourth is, we have already discussed this. The fourth is on the basis of explanation type, and we have already discussed that there are four kind of possible explanations for our black box. One is visual, feature importance, data point, and surrogate model. So we have listed all these points here, that explanation type can be visual, feature important, data point, and surrogate. So these are the four categorization. First, on the basis of agnosticity, whether it is model specific or it is applicable to all the models. Second is on the basis of scope, whether it is local or is it global, that it can be it is used to generate explanation for single record or for all the record. Third is on the basis of data type, whether your approach is used for textual data, tabular data or image data. And fourth is on the basis of explanation type. And these four are various categorization of explainable AI techniques. So all of these explainable AI techniques can be categorized into these ways. So at this point, if you have any question, you can ask. Okay, so now it is the time for demonstration. So now I'm going to demonstrate that how actually explainable AI works. So for this, I'm recommending you a website. For called as heatmapping.org. .org. So let me share this also on your chat box.
Which site, sir? Please repeat.
Okay, I have shared this on your chat box. So the name of the website is heatmapping.org. You can open this website from your laptop. So in this website, we can see explainable AI models directly in action. This is the website which is developed by some German scientists who have worked a lot on explainable AI. And in this, you will be getting a link. So if you scroll down, you will get something interactive LRP demos. So you can click here. So if you click here on demos, it will open a new page where you can see explainable AI demonstration for 4 different projects. First is handwriting classification. Second is image classification. Third is text classification. And fourth is visual question answering. So I'm going to demonstrate each of these applications one by one. So first is handwriting classification. So in this draw a digit, you can draw any digit. So let's suppose I have drawn a letter. So let me draw it again. So I have drawn this letter. So you can see that I have drawn 7. And on this, the prediction is 7. And it is generating a heat map. It is actually generating the information of the pixels in different colors to indicate that what are the important pixels responsible to classify this digit as 7. You can see that there are 2 important strokes in this. One is this stroke, which shows that it has some vertical line. And second is this stroke, which shows that it has some horizontal line. So it is indicating those pixel areas which are important for identifying this digit as 7. And you can understand this, that this model is applying explainable AI on image, and it is showing the pixel areas which are important for identifying this object as 7. And you can see that there are 2 strokes which are indicated in red color. One is horizontal and another is vertical stroke. And due to these 2 strokes, this digit is classified as 7. You can try various digits here and you can see their corresponding output. So this is 3. You can see that these are important strokes that this particular digit is classified as 3. So this way you can generate the heat map for any selected digit. You can even try digit from here and it can generate explanations with the use of heat map that why this particular digit is classified as 4. So this is about handwriting classification. You can even apply explainable AI on various images. So here I have selected this image classification. In this you can select various image. So let's suppose I have selected this. So it will generate explainable AI and heat map. So you can see that this is tabby, which is classified as a type of cat. And you can see that these are the pixel areas which are responsible to identify this object. So this is the heat map, and these are the pixel areas which my model is looking at in order to classify this object as cat. Let us apply this over this. So here the information is again tabby, which is a type of cat, and you will see that these are the pixel areas which are important. So these are the features which model is looking at in order to classify this object. Let's try this. So it is a house finch, and you can see that these are the pixel areas which are important. You can see this galgi and mouth and all those parts which are important to identify this as house finch. So this is very interesting, and you can try it on your own, and it will generate heat maps to show you the corresponding explanation that why this image is classified as a particular class. And these are the way actually we can apply explainable AI on image data. We can also apply explainable AI on textual data. So you know that at present you are using sentiment analysis system where you have some input sentence and your model is saying that whether this sentence is positive or negative. Similarly, you have some kind of document and you can check its class that whether this document is on politics or whether this document is on technology, whether this document is on sports. So this type of classification is called as text classification, and you can apply explainable AI on textual data also. So here you can load some random documents. So let me load this. So let's suppose this is my document and I want to check what is its class and why. So just click here classify. So it has checked that this document belongs to computers, OS, Windows, and miscellaneous. Now the question is why this document has been classified as a computer. So it is highlighting various keywords that why this has been classified as computer. So you can see that computer, then MS, change, computation. So these are the words which are highlighted, which indicates that these are the important words due to which it is considered as a document of computer and Windows. So this is very important, and you can apply explainable AI on textual data. And instead of just saying tweet is positive or negative, it can highlight those words which are responsible to classify a tweet as positive or which are responsible to classify a tweet as negative. So let's check this for this. So this is computer and graphics. So why this is considered under graphics? So you can see that here it has highlighted RGB, BMP. So due to presence of these keywords, it has been classified as computer graphics. This is very important information, and it can assure you that yes, this is a correct classification because it has highlighted appropriate words for this classification. So you can try it on multiple documents and it will generate its explanation by highlighting keywords which are relevant. Again, it is computers, OS, Windows because it has modem, because it has directory and so on. So these are the keywords which are highlighted in different colors. So this is the way you can apply explainable AI on textual data. So we have discussed that explainable AI can be applied on handwriting recognition, image classification, text classification, and last is visual question answering. So we can even ask a question on the image by using explainable AI. So let's suppose this is my input image, and you can ask that, do we have trees in this image? So I have asked a question, so just press enter. So it will process this image and it will generate its response by, so it is taking some time. My internet is also a little bit slow maybe. So you will be getting some kind of output in the form of yes or no, and it will highlight those pixel areas of the tree because the question is on tree. So there is issue of connectivity. So let me run this again. Yeah, so you can see that I have uploaded this and my question was, do we have trees in the image? And the model is saying yes, and it has highlighted this area. So this area has been highlighted. You can see dog has not been highlighted. So it is some green part which is highlighted and it is generating the output in this. So let's suppose this is my image. So I am asking, do we have bird in this image? It's a no. So model is not able to identify it properly. It is 50-50 chance in this case. So let's check this input image. So I am asking about the animal. So what is the animal in this image? You can see that the model is saying this is elephant, and these are the pixel areas which are highlighted for this. So important is the pixel areas. So the model is automatically highlighting those pixel areas. Here it has highlighted the pixel area of elephant to answer this. So let's check this on grass. So here I'm saying that grass, and it is saying that grass is green. So you can see now, this time the pixels are grass. There is no pixel for elephant. So the model is looking at grass now, and it is there is the grass is green, it is tall, it is wide. So I hope you got my point. So you can apply these tools to generate explanations. So you can apply explainable AI on handwriting, image, text classification, and visual question answering. If you have any question at this point, you can ask me. Yes, please.
Hello, sir. Good morning, sir. Good morning, sir.
Yeah, good morning.
Okay. Thank you so much for the lecture. My name is Woko. If you are asking the Google chat on the features to be collected or features you feel are of great importance, how do you report its level
Pardon,
of?
can you repeat your question again?
And I'm saying, if you are using the Google chat, the chat box to specify the features you feel is of great importance, how do you report that? Are you reporting based on accuracy or based on are you reporting based on accuracy of its importance, or you will report it based on the questions you ask? I don't know if you
So,
understand.
Yeah, so we are generating the output on the basis of accuracy. So when I input the image, so it is actually giving me the confidence of the model in that prediction. So, so for example, if I'm asking that is there any player on this, so it is giving me some kind of confidence. So these percentages actually refers to the confidence of my model in making that prediction. So it is not actually the accuracy, it is actually the confidence in that prediction. So you can take it that way. So this is actually all the confidence that the model is saying it green with 41% confidence, and it has a 38% confidence for tall, and for wide it has 3% confidence. So normally we go with the class which has the highest value of probability, or you can consider this as a probability, that the probability for green is 41, while tall is this 38 and so on.
Okay.
I hope you got my point.
Yeah, thank you.
So now it is the time for a quiz. If you have any other question, I can take one more question. Anyone, please? So let's make a quiz so that this is an informal quiz, and I hope you will enjoy this. So let me present this. So now I request everyone to please join this quiz, which is available at menti.com. So you can open this website from your mobile or from your laptop, and it will ask for a code, and the code is 713417, which is displayed here. Even I am also sharing this on your chat box. So you can click on the link which I have shared on the chat box to join this quiz. So please everyone join this quiz.
Sir, code please.
The code is 71341753. 713 41753. So I'm waiting for all the players. We have a lot of participants, so everyone please join in. How many participants we have? We have 85. So please quickly join. So it shows that how many are actually listening. So please join quickly. So this is just like a KBC, fastest finger first. For every question you will be getting 15 seconds to answer. The person who answers correctly and fast will get maximum point. And this is accumulative. Your point will be added after each question. And finally, you will be getting the numbers after the end of 5 questions. So let's start. So you will be getting the question on your screen. Just a minute. So a lot of confusion. Regression is actually logistic regression. So we discussed that this is a case of glass box where you can see and interpret. So interpretable models are called as glass boxes. They are not black boxes. So the answer is glass box. So let's see the score. So at present Rabina is on number 1. So this is your score. So let's move next. Question number 2. Now we have 33 players. Good. Yes, so this is black box. Very good. This time it is correct for most of them.
So next time it says the code is not found.
So you have to open menti.com and the code is again 7134175. I'm also sharing the link. You can click on this link to open it. So let's move to next question. So we have now 41 players. Good. What if tool is based on data points? Visual is just correlation points. Let us move to second last question. We have total 5 questions. This is second last. So Lime is actually a surrogate model. We discussed it. let's go to the final question. So if you can click on any model, we call it as agnostic. Global and local is for record. So here we are talking about if you can apply it on sport vector machine, naive base, decision tree and all. So it is model agnostic. So let's see who is our final winner. So we have 7141759 as the winner. So who is he? Please unmute yourself and please introduce to all of us. This is your time. Please unmute and introduce yourself to all of us. We have second as Sakura. Please unmute yourself and introduce to all of us. It will be great.
Thank you very much.
Please introduce yourself.
Your points. There is some new mining research.
Okay, good. From which college?
I am Government Degree College, UD, GMK.
Okay, good. So congratulations.
Thank you, sir, and this is very inspiring lecture. We have learned a lot of things. Thank you very much for such a lecture.
Thank you. Yeah, so we have second as Sakura, third is SK. So whose name is displayed on the screen? You can unmute yourself. Kavita, Simba. So for all of you whose name is there on screen, top 10, please unmute yourself and you can introduce to all of us.
So this is Kavita from Ishwar Engineering College, Chennai, sir. Very nice session, sir. Very useful. I'm just doing work on text mining. Just really nice session, sir.
So I hope you can apply explainable AI on textual data.
Yes, sir. Thank you.
Ji, good afternoon, everyone. So your session is very informative and valuable. I'm Harneet Kaur from UIC, Chandigarh University. Duma.
Thank you. Yeah. Next.
Very good afternoon, sir. I'm Ritika Goyal, faculty member, Kachua Campus, University of Jammu. Your session is very, very informative. We really learned a lot from this session. Thank you very much.
Thank you. Yeah, next. Yeah, this is your time. Please don't hesitate. If your name is displayed, please unmute yourself and introduce.
Sir, this is Dr. Gautam here from Government Degree College.
Oh, good. Nice to connect with you. Thank you.
Your lecture was really very informative, sir. Surely have been. Thank you very much.
Thank you. Anyone else, please, quickly? Yeah, please. This is your time. Anyone? You can unmute. Yeah. So at this point, yeah, please. Continue.
A few of them have actually written in the chat box. Maybe there is some problem in the voice. Yes.
Okay. Thank you. So let me read this.
Sir, very nice session. Thank you so much.
Thank you. Thanks for giving me opportunity. Okay, I got your information. Yeah. Okay, so now I'm going to share a few more resources if you want to learn more on this.